Okay, we are in section 1.3, which is identifying, adding, and subtracting polynomials. Okay, so first, let's start off by talking about what is a polynomial, right? Polynomial. All right, so I think honestly the best way to learn what a polynomial is to look at them, right? So we'll start off with our first example here, and I will write out a polynomial. So 7x cubed minus x to the sixth plus 7 plus, let's say 3x to the 13th power. Okay, so this is a polynomial, right? Some things to kind of pay attention to, right? What differentiates a polynomial from a non-polynomial? Well, all of my variables have exponents that are positive whole numbers, okay? You don't see any fractions. You don't see any negatives, okay? So positive whole numbers are the exponents on my variables, okay? So, and then you see that it's broken up into multiple terms, okay? I see 1, 2, 3, 4 terms, okay? That's 1, 2, 3 positive terms and 1 negative term. Okay, so those are things we can kind of pay attention to. Okay, so this is a polynomial. Now, typically, you want to write them in order, okay? And what I mean by order, I'm talking about descending exponents. So descending powers or just descending exponents for the order, okay? And so in other words, find the biggest exponent. That would be this 13 right here. So this term, this positive 3x to the 13th power, will be my first term. Okay, then I will look for my second largest exponent. I see a 6 right here, so that's my next term. This right here is my next term. That's a negative x to the 6th. Okay, then I look for the next biggest exponent, which would be 3. So 7x to the 3rd. It's a positive 7x to the 3rd. And then finally, I have this plus 7. Don't let that term right there fool you, okay? That is still a term. I don't see the variable there, but I know it's still one of the terms. So there we go. It technically has an exponent of 0, right? You have 0 x's present, so you can think about that as x to the 0 power, although you won't see it written. Okay, so there we go. We have it in descending order of exponents. Okay, part B. Something else to identify, and this one's kind of important, especially once you get to college algebra. You want to be able to recognize the degree of the polynomial. Okay, the degree is just the highest exponent. The highest exponent. So in this case, that would be 13, right? 13 is the highest exponent, so my degree is 13. Basically, you can ignore the rest of it, right? Just want that 13. All right, and then the last part we want to identify real quick is the leading coefficient. Okay, so first of all, a coefficient is the number in the front of the variable. Okay, so I see I have a 3. That's a coefficient. Here's a -1 coefficient. Here's a +7 coefficient. And this one technically can count as a +7 coefficient if you think about that as x to the 0 power attached to it. Okay, so get rid of all that. Okay, so the leading coefficient is the coefficient, right, the number in front of the term that has that biggest exponent. Okay, so once you identify the degree, your eyes are kind of focused in right here, right? You're ignoring all that stuff. This 3x to the 13th power is what I'm looking at to determine the degree. And so the leading coefficient is the 3 that's attached to it. Okay, so it's 3. Let me not erase too much here. 3. Okay, so there we go. That's a good introduction to polynomials. Let's do one more very similar question. Example 2. Okay, and I want to do the exact same thing with this polynomial. So -10 plus y to the 8th minus 9y squared. Okay, so first I want to put it in descending order of powers. Okay, so I look for the biggest exponent. I see this y to the 8th. It's actually a positive y to the 8th, so I'll put that first. Positive y to the 8th. If it were a negative y to the 8th, of course, you just put a negative there. Okay, then I see y squared, so negative 9y squared, or minus 9y squared, and then minus 10. Okay, there we go. Now it's in the order that they prefer. Part B, we want to know what's the degree. Again, the degree is the highest exponent, so my eyes are kind of drawn here for the highest exponent. That exponent is 8. And then leading coefficient. Okay, well, again, I'm looking right here. What's the number in front of the y? I don't see one. It's understood to be a positive 1, right? An understood positive 1. So my leading coefficient is 1. Okay, so now we know what polynomials look like. Let's kind of take this to the next level, which would be for the next, 5 examples or so. Identify whether or not the expression is a polynomial. Okay, polynomial. And if it is, let's find the degree and the leading coefficient. All right, so that's what we're going to do. So, example 3, we have negative 12y plus 5y to the 7/5 power. Okay, so I see that ugly 7/5 power, right? I don't like the fraction exponent. Luckily, we just talked about that, right? Polynomials have positive whole number exponents on the variables, okay? This is a positive fraction, okay? So this is a non-polynomial. So I'm not going to worry about this one. I don't have to find the degree because it's not a polynomial, so I can't answer the polynomial questions. Okay, let's go to example 4. Okay, example 4 says same thing. 4x to the 6th y. Oh, this is tricky. Plus 5y squared. So here we're mixing the variables. There's x's and y's. So we need to be careful with that. It's actually not any more difficult. So let's kind of talk about how to handle this. Okay, so the first part of the question is to determine whether or not it's a polynomial. Well, I'm looking at the exponents and I don't see any negatives. I don't see any fractions, right? So maybe we want to say something about this understood 1 right here, right? But I don't see any negatives, no fractions. They're all positive whole numbers. So this is a polynomial, even though it's kind of written weird, right? It has x's and y's. It's a polynomial. And then a moment ago, I said, well, if it's a polynomial, let's find the degree and the leading coefficient. Feeling lazy, so I'm not going to write out the whole thing. Okay, the degree is the highest exponent. Well, in this one, you got to be a little careful. This is where this gets tricky. This is one term that has 2 exponents. Okay, so I'm going to actually add those 2 exponents together. Okay, so 6 plus 1 would be 7. So the degree is 7 compared to right here where it's 2, right? So 7. All right, that's not too bad. And then the leading coefficient, well, I've identified this as that term, that leading term. The number in the front of it is a 4, so I know my leading coefficient is 4. Okay, so it's not so bad, right? The only thing really different here is you add those 2 together. Let's go on to example 5. All right, so identify whether or not this is a polynomial, and then if it is a polynomial, find the degree and the leading coefficient. All right, so there we go. 4y to the 11th plus 3x to the negative 9th, y to the 11th plus y to the 3rd, and right away this jumps out at me, this negative 9 as an exponent. Nope, can't have it. This is a non-polynomial. Exponents must be positive whole numbers. Okay, example 6. We have 8x to the 3/4 power. All right, I'm not going to spend a whole lot of time thinking about that. I see that fraction exponent, and I know this is not a polynomial. Okay, polynomials are nice, right? They behave when it comes to their exponents. Okay, and so we don't want to deal with those fraction exponents, so we don't have to. All right, here's a somewhat trick question. I say somewhat a trick question. It's not really a trick question, but you know. Negative 16. All right, polynomial or not? Okay, well, I don't have any negative exponents on the variables because I don't have any exponents or any variables. And I don't have any fractions for my exponents on variables. Again, I don't have any variables. So this one's a polynomial, right? It's kind of tricky because we're trained to look for these positive whole number exponents. But remember, you know, if I don't see any negatives, if I don't see any fractions, it's okay, right? It's a polynomial. This is actually one of the nicest polynomials you'll ever find. It's just a number. Okay, so if it's a polynomial, let's identify the degree. Oh, that's kind of a trick question. And the leading coefficient. I'll write it out this time. Leading, if I can push the right button, that'd be nice. Leading coefficient. Okay, so think back to what I said earlier. All right, negative 16. I can think about that as negative 16x to the 0 power because there are 0 x's present, right? 0 x's being multiplied in there. So if I think about it like that, then my degree has to be 0. Anytime you have a constant, right? This is a constant. Anytime you have a constant, the degree is 0. Okay, and that number, negative 16, is my leading coefficient because it's my only coefficient. Okay, so don't let that problem trip you up. It is a polynomial. The degree is 0. It's also the leading coefficient. Okay, so that is polynomials, degrees, and leading coefficients. Now let's actually talk about the second part of this lesson. Remember, we talked about identifying polynomials, which is what we've been doing. Now we need to talk about adding and subtracting polynomials. And I promise this is something you've already done at this point. It just is presented a little differently. Okay, so adding and subtracting polynomials. So the instructions here are to add or subtract the polynomials. All right, so example number 8. We have negative 5x to the third plus 11 minus 6x plus 5 plus 8x minus 9x to the third. Okay, so I'm adding these two polynomials. They are polynomials, right? Positive whole number exponents. Here's a 3, x to the 0 is technically here. That's a 1 there. Okay, so everything's good. Same thing here. This is x to the 0, first power, and then 3. So no worries there. If I'm going to add them, the easiest thing to do is to take care of the parentheses first. Now remember, there's technically always an understood 1 hanging out in the front of them. Okay, so you can think about it as, if I want to get rid of those parentheses, let me multiply everything by that 1. Okay, so 1 times negative 5x cubed is negative 5x cubed. Okay, 1 times 11 is 11. And 1 times negative 6x is negative 6x. You see, you could have just actually not even bothered with the multiplication part, right? You could just drop the parentheses off. It's the same thing. Okay, and then the same thing here. So 1 times 5 is 5. 1 times 8x is 8x. And 1 times negative 9x cubed is negative 9x cubed. Okay, so how much fun is that? Okay, why is this fun? Because this is actually something we've been doing, right? This is just combining like terms, right? I'm combining like terms. So what are my like terms? Let me color code this a little bit. Negative 5x cubed, negative 9x cubed. Negative 5 minus 9 is negative 14x cubed. Okay, I have a constant 11, positive 11, and a positive 5. 11 plus 5 is a positive 16. And negative 6 plus 8, right? Negative 6x plus 8x, they're like terms, so negative 6 plus 8 is a positive 2. So positive 2x. So there we go. Maybe I want to write this in descending order of powers, right? So I'll put x cubed first, then x, then the constant last, right? There we go. Yeah, this answer would actually have been fine as well. Okay. Unless they explicitly ask for it to be in descending order, you don't have to put it in descending order. However, you want to be in the habit of writing it that way. It just makes it a lot easier to work with. All right, let's do a couple more examples. Negative 6y to the fourth plus 7 minus 3y squared minus 10 minus 5y to the fourth. When it's subtraction, you got to be a little bit more careful than you did with the addition problem. Okay, so just like in the first one, there's an understood one here. If you multiply this out, you just get whatever's in the parentheses. So I'm just going to do that. I'm going to get 6y to the fourth plus 7 minus 3y squared. Going to skip that whole multiplication step. That's always going to be the case. But not necessarily right here, right? Because this 1 right here is technically understood to be a negative 1, right? It's a negative 1 that's being distributed. Okay, well, what happens if I do that? Negative 1 times the 10 is negative 10. Negative 1 times the negative 5y to the fourth is a positive 5y to the fourth. So it changes your signs, right? That's kind of normal, right? If you subtract a positive, you end up with minus. If you subtract a negative, you end up with a plus, right? So all that's the same. It's just, got to watch for that. Okay, so like terms. 6y to the fourth plus 5y to the fourth is 11y to the fourth. Positive 7 doesn't, oh, yep, there is a constant, another constant. Minus 10, 7 minus 10 is negative 3. Negative 3y squared, there's nothing to pair that up with, so it's just going to stay there as minus 3y squared. Again, I'm trying to get in the habit of writing these in descending order, right? So I'm going to go ahead and rewrite this as 11y to the fourth minus 3y squared minus 3, right? Just move that one here and that one there. All right. That would be example 9. Now let's go on to my final example 10. So xy minus 4x plus x cubed y plus 9x minus xy cubed minus xy. Okay, this is almost designed to confuse you, right? Let's kind of look at this. This term here and this term here are not like terms, right? They look alike. They look a lot alike, but that's just designed to look that way, okay? The big difference, obviously, is the 3 here is an exponent on the x. The 3 here is an exponent on the y. So not the same thing. When I'm combining my like terms, I don't put those together. All right, let's go ahead and drop the parentheses. So we have xy minus 4x plus x cubed y. Again, technically I'm distributing this 1. But, why do the extra work? Same thing here. This is a positive 1 this time, not a negative. It's a positive 1, so I can just distribute it again and, get the same thing. So that's going to be plus 9x minus xy cubed minus xy. Okay, no signs flipping there. Okay, so like terms. Okay, I do see some, right? xy minus xy. Oh, those cancel out. That's great, right? Those, boop, gone. All right, what else is left? How about this negative 4x and this positive 9x? What's negative 4x plus 9x? 5x. Okay. Plus x cubed y. Well, we just said that that's not the same thing as this one, right? Not the same thing. So I have to leave it separate. And minus x y cubed, nothing to pair that up with. All right, and then here, it actually doesn't make much sense to put this in decreasing order of exponents. Typically, when it's like this, though, I guess it does make some sense. When it's like this, you want to focus on the x's, right? So x cubed is what I would put first. Then these two are about the same, but this one has an extra variable attached to it, so that would be the next one I would put. And then plus 5x last. So there we go. All right, so that's identifying, adding, and subtracting polynomials.